Welcome Algebra 1 students to our first video on material that was not covered last year, except in the couple of classes where teachers did a little bit on the extra side. So the music hopefully will click in a moment and we'll be able to actually hear it. But we're going to be looking at literal equations. Literal equations are the same thing as formulas. And this video is also known as, what happened to all the numbers? There's our music. Okay. So let's get started by talking about what we're actually referring to when we say literal equations or formulas. Formulas, or literal equations, many problems in algebra require the use of formulas for their solution. A formula is an equation that shows a relationship between one or more variables. Here are a couple of formulas you should be familiar with. This one, A equals 1/2 times B times H. That's the area of a what? A triangle. P equals 2L plus 2W right here. That's the perimeter of a rectangle. And then this one over here may not look familiar. Y equals mx plus b. You will know this one before too long. This is the formula for a general formula for a linear equation, for an equation that makes a line on the coordinate plane. So what are we going to be doing with these formulas? Well, we're going to be manipulating them. Manipulating, which really is just a fancy way to say that we're going to be rewriting them. Rewriting them so that while they mean the same thing, they will be in a different order altogether. So we're going to solve for a variable. So here's our first equation, D equals RT, and this is distance equals the rate or speed. Sorry, that looks like a Z. It's supposed to be an equal sign. I was rushing. The rate or the speed times the time. So like if you're going 50 miles per hour times 3 hours, you're going 150 miles. Oh, let me put the unit on that. That's what this formula is. And so when we say we want to solve for t, we want to get it so that t is by itself. We want t to be by itself. Well, let's think about the equivalent equation, analogous equation. 3 equals, let's say 33 equals 11x. 33 equals 11x. If I needed to solve for x, I would divide both sides by 11. The 11s would cancel, and x would be equal to 3. Well, what's analogous to that here? We have d, that's in the same spot as the 33, and we have r times t. Think of the t as the same thing as the x. Think of the r as the same thing as the 11. So just because we don't see any numbers doesn't mean we can't use our properties of equality like we did when we were dealing with equations with numbers in them. So what we're going to do for this problem is we're going to take both sides and we are going to divide. Well, what are we going to divide by? We're going to divide by r. If you can divide both sides of an equation by 11, you can divide both sides by r, because r represents a number just like the number 11 is a number. Now on the right-hand side, the r's are going to cancel with each other, and you're going to have t by itself, and it's going to equal the fraction d over r. Now over here, we can divide 11 divided by 33. That's why I picked the numbers. We got 3. But over here, we can't. So we're just going to leave it d over r. And now, if I have a problem where I know the distance and the rate, I can find the time. Because in the original formula up here, I would need to take and actually write an equation to solve. If I had the distance and the time and I wanted to find the rate, now I can just solve it by plugging in the numbers. So this is an important skill. We're going to have to be able to manipulate lots of equations as we go through Algebra 1. Let's try another one. Okay, let's look at this one. We're going to solve this equation for x. We have y equals mx plus b, or m times x plus b. So this time, I have a little bit more to do. Let's again think about an analogous equation. Let's think about 11 equals 3x plus 2. Well, what would I do first here? We know that we're supposed to use the order of operations in reverse. So there's my order of operations. We're supposed to go this way. Additions and subtractions, then multiplications and divisions, and we don't really think about these two. So if I was solving this, I would subtract 2 first from each side. Well, we're going to do the same thing over here. So I'm going to write the equation again so you can see the original one. We're going to start off by reversing subtraction, which means subtracting b from each side. Now over with my example equation, oh, my 2 is missing its head. There we go. With my sample equation, we get 9 when we subtract 11 minus 2. But we can't do that over here on the left-hand side of the screen. Here, we just have y minus b. We can't write it any simpler than that. So that's the fundamental difference between what we're doing when we solve a regular algebraic equation and what we do when we're solving a literal equation. You're still all variables. As long as you're following the rules of math, it's going to work just fine. What would be the next step over here? Would be to divide by the coefficient of x. And we get 3 equals x, or x equals 3. What's the next logical step here? Again, divide by the coefficient of x. Leaving me x equals y minus b over m. And please notice, I didn't change anything. I canceled out the m's. So I had x equals y minus b over m. I just rewrote it with the x on the left-hand side. So that's solved for x. The relationship between these variables is exactly the same as the relationship between these variables. It's just rewritten. It's just rewritten. Let's try another. Okay, this time we're going to solve for L. This is a cursive L up here, L. All right, no more analogous equations. We're just going to do this one. So I want to get this L by itself. I'm not going to start by dividing by 2 because I need to reverse additions and subtractions first. So let's subtract 2w from each side, leaving me p minus 2w equals 2, and use a cursive L so that you don't think it's a 1. Now, I know I told you not to use L, but we don't really have a choice here because this is an actual formula, perimeter formula, and it has an L in it, so that's what we're going to have to use. How do I finish it off? Well, I reverse the division. So I reverse the multiplication, excuse me, with division. So we have L equals p minus 2w over 2. Okay, and that's it. That's solved for L. We isolated L. So solve for a variable is also known as isolating the variable. So isolate the variable means the same thing as solve for the variable. Another. Okay, this time we have a equals 1/2 bh. That's our triangle formula, like we talked about earlier. Now this time we don't have any addition or subtraction to reverse, but we do have this pesky 1/2 here. Now I don't want to see you divide by 1/2. We've already talked about in class, that's not advisable. That's not what we want to do here. Okay, so that's not right. So not dividing by 1/2. Well, what does the same thing as dividing by 1/2, but gets rid of the 1/2 on that right-hand side? Multiplying by 2. Multiplying by 2 gets rid of that 1/2. So 1/2 times 2 is 1, leaving me BH on that side and 2A on the other side. And leave it 2A, no dot, no multiplication symbol, no parentheses, just write it 2A. Finishing off solving for H, we're going to divide off the B. So H equals 2A over B. Or, to find the height of a triangle, if I know the area and the base, multiply 2 times the area, take that result, and divide the base. So again, manipulating the formula. Moving stuff around still means the same thing, but it looks different, and it might be useful in certain circumstances. Another one. Okay, this time we're solving for C. Solving for this C right here. The nature sounds on the iTunes radio are getting to be a bit much, so we're going to skip the nature sounds. Thank you. Oh, that's better. Okay, big fraction, right? This looks familiar. We've been working with stuff like that in class. Big fraction. We start off by multiplying both sides by the denominator of the fraction to get rid of that fraction. That's what we do. So we're going to do the same thing here. We're going to multiply both sides by n. We're going to multiply both sides by n, canceling the fraction on the right, leaving c minus s, and this is dn. And the only reason I wrote it that way is because it's alphabetical order, and that's a tradition in math. I wouldn't mark it wrong. The commutative property says it could just as easily have been n times d, but we're going to write it that way for tradition's sake. And again, we're finishing off solving for c. So now I'm going to add s to each side to get rid of that minus s. And that means c equals dn plus s. Now, why couldn't we start off by adding the s? Because this isn't really an s. It's an s over n. So if you follow along C's journey, first C had s subtracted, then the result was divided by n. That's why you have to go backwards, work your way backwards by multiplying first to get rid of this, then adding the s to finish it off. No real way to check these. There's no real way to check these because you can't go back and necessarily plug in what you got. Now, it will work, and I may actually even show you that in class, but that's just an aside. It's not something we're going to be able to recognize as useful yet. So we're not going to be able to check them. You just go back and you look at the math you did and make sure the math you did makes sense. Okay, let's look at some more. All right, now I know you're thinking, oh, come on, Ms. LeCompte, that's 8 equations. We're only going to do 4. We're only going to do 4, okay? Let me pick which 4 real quick. We're going to do this one. We're going to do this one. We're going to do this one. And we're going to do this one. Okay, so those are the 4 we're going to do. Now, I want you to copy down those 4, or all 8 if you want for the extra practice. Can't hurt. And I want you to try them yourself. So pause your video, copy them down, try it yourself. But I'll go ahead and write them out now. All right, so if you're not going to pause your video, here they come. If so, pause it now and try them on your own. P equals IRT, which is a little bit of an equation we've used, but it's actually kind of adjusted around. I want you to notice that you have all multiplication right here. It's I times R times T. So you can actually get rid of both of the multiplied variables in one division step. So P over IR, and the I and the R cancel on the right, equals T. P over IR equals T. And that one is finished. T is alone. T is isolated. Next one. The next one looks a lot like y equals mx plus b, except it's y equals 5x minus 6. So there are a few numbers in some of these formulas, as we've seen here and there. Again, we're going to reverse addition and subtraction. So in this case, reverse subtraction, add 6 to each side. We get y plus 6 equals 5x. Then we reverse the multiplication by dividing. So divide both sides by 5. And that means y plus 6 all over 5 is equal to x. And that one is done. Next one, we've got a big fraction again. So I'm going to take my big fraction, and I got to remember that even though I want to get that x out of there, and I want to get that, I want to get that y out of there to get x alone, first I got to deal with this divide by 3. Because that was done after the addition. That was done after the addition. In this problem, the multiplication is done before the subtraction in order of operations. Here, the addition is before the division, so we reverse the division first. 3's cancel on the left. X plus y equals 15. Subtract on both sides, subtract y. X equals 15 minus y. And we're done with that one. Last one. Again, this one is kind of messed up. I should have put the little parentheses in there before. So this is the formula for actually the area of a trapezoid. It's the formula for the area of a trapezoid. You're used to seeing, instead of b plus c, you're used to seeing b1 plus b2. This is just another way that you'll see it maybe in a different math book. So we've got to, and I'm going to work above the problem because I'm out of space, we've got to start off by getting rid of our 1/2. Now again, I don't want to distribute. If I'm trying to solve for C, distributing makes, for B, distributing makes the term more complicated. It encumbers it more. We want it unencumbered. We want B by itself. So leave B alone. Leave B alone. Let's start off by multiplying both sides by 2, just like the one with the triangle, because the 2 times the 1/2 gives you 1 and cancels. So 2a equals h times the quantity, b plus c. Now, instead of distributing, divide off the multiplied h. So 2a over h equals b plus c. And finish off by subtracting c, which gives me 2a over h minus c equals b. Please do not panic if this is tough for you, especially if everything else leading up to this has been, quote, easy, unquote. I've heard a lot of, oh, this is so easy in class. That's fine. But you're not the only one there, and not everyone is necessarily feeling that way. And while you might find this challenging, someone else is saying, oh, this is so easy. All right, so I really want you to recognize here that while it's new, it's really not that complicated. I'll see you guys in class.